So for graphs of logarithms, we first of all look at y equals 2 to the x. That's our old friend, the exponential graph. And if we're saying that the log graph is the inverse function, then we just switch the x and y's. So remember, the 0, 1 becomes 1, 0. The 1, 2 becomes 2, 1. And the 2, 4 becomes 4, 2. And how about this? The 3, 8 becomes 8, 3. 2 to the third is 8. The exponent of 2 that gives you 8 is 3. So we can see, just like in all inverse functions, the graphs are symmetric to the line y equals x. The green line is the line y equals x. The blue line is the exponential function. The red one is the log function. Algebraically, remember, you take the function, replace f of x by y, switch x and y, and how do you get y by itself? Let's see if this works. The exponent of 2 that gives you x is y. And sure enough, if I just read it correctly and fill in what everything means, I get the y by itself. And the y in this new function is the inverse function of x. In the red graph, at x equals 0, I'm approaching 0 from the right. The y value is going towards negative infinity. To the right, as x goes to the right, y is going to infinity. It looks like it flattens out, but it just keeps growing, just very slowly. You're right. If I go out to 2 to the 10th, 2, and this is 1024 over here, I'm only going to go up to 10. It is going up though. So looking at example 5, we can see that the only difference is the bases are changed. Let's take a quick look at a couple of exponential functions. That if this is the point 4, 1, the exponential is the point 1, 4, which means what to the first power is 4? Well, 4 to the first power is 4. Same thing here. If we have the point here of 3 gives us negative 1, then negative 1 gives us 3. Let's fix this graph. I think I made a mistake. So that point is 3, negative 1. The inverse is negative 1, 3. And the graph will look something like this. And so, since this is 4, that's the one with a base of 4. If this is 3, that's the one with the base of 3. If this is 7, that's the one with the base of 7. This one is flipped, and that's why the base is 1/3, and that's choice 2. Again, when we graph by transformations, we need to have a basic graph. So here the basic graph is y equals log base 5 of x. And so there's that 0.10 that we always have. And if the base is 5, we have the 0.51. So this dotted graph is our parent function. And that'll take care of our 2 points. And then if I take that log graph and move it to the left 3 units, this point goes to the left 3 units, and this point goes to the left 3 units. The vertical asymptote used to be x equals 0. Now the vertical asymptote is x equals negative 3. and I have the new solid blue graph. The graph goes from -3 to the right to infinity, and it goes down forever and up forever. Here, the basic function is y equals base 4 of x. Again, we have the point 1, 0, and because the base is 4, we have the point 4, 1. The negative flips the x values, so this x value of 1 becomes -1, this x value of 4 becomes -4. I take the y values and double them, so this y value of 0 stays 0, but this y value of 1 becomes 2, and so our graph stretches a little bit up and down, but it still has x equals 0 as the vertical asymptote because we just flipped it over the y-axis. So domain from left to right, -infinity to almost 0, and then bottom to top, it goes from -infinity to infinity. Our parent function is y equals log base 3 of x. There's our friend 1, 0, and because the base is 3, there's our point of 3, 1. As usual, the vertical asymptote of x equals 0 is our starting point. And then we take this graph, and we move it to the left 2 and up 1. To the left 2 and up 1. So I take this point to the left 2, up 1, and this point to the left 2 and up 1, and the vertical asymptote goes to the left 2. That's all I care about. You can also say it goes up 1, but you won't see it. And so here's our final graph. D is the tough one. Here's what they give you here. If I write it this way, it's still -x plus 1, but this way I see the flip and the shift separately. It's kind of hidden, so we have to be careful. Okay? So again, our parent function is y equals log base 6 of x. Here's our point 1, 0, and our point 6, 1 because of the base of 6. So the negative here, or here, is going to flip the graph over the y-axis so the x's change. So this point goes here, and this point goes here. Next, I take the y values and multiply by 5. Well, the y value here is 0. Multiplying by 5 still gives you 0, but the y value here is 1. Multiplying it by 5 gives us 5. Then I do some shifting. I take the graph, shift it to the right 1 and down 4. So this point goes to the right 1 and down 4. And this point goes to the right 1 and down 4. So that, sure enough, I have this final graph. This is to the right 1. Our vertical asymptote is x equals 1. Let's go back and do the domain and range for C. The domain goes from -2, vertical asymptote, to the right infinity, and the range always goes from bottom to top forever. For D, the domain goes from the left -infinity up to almost 1, and the range always goes from forever down and forever up.